am Anil Kumar. Welcome to my series on trigonometry. In this particular video, we will see how should we solve trigonometric equations, especially when the angle measurements are in radians. We'll start with simple questions with trigonometric ratios equal to some real value and see how do we find that and the angle for that in the given domain from 0 to 2 pi. And then we'll take up linear trigonometric equations and work out with different domains. Let us say from minus pi to plus pi. And then we'll take up some complicated questions which will involve quadratic trigonometric equations. And finally, examination style questions where you might have to prove an identity and then solve the trigonometric equations. So let's go through these questions. I hope they will help you to understand the complete concept and gain confidence in solving such questions. Let's see how should we solve these questions.
In this video, we'll look into the details of solving trigonometric equations. The angles will be in radians. You may take this as an assignment for trigonometric equations. There are 13 questions in this assignment. These questions are taken so that you can understand from basic concepts to what really comes as challenge questions in test papers. So we have selected the questions from past papers, and I hope that will help you to understand the topic and also perform well in your own exam. In case you want to learn from me, you can always send an email on the address given here. At present, you can see 11 questions on the screen. Let us go through these questions before answering them. The very first set of questions is solve each in the interval 0 to 2 pi. Provide exact solution or round to 2 decimal places. For all these equations, 6 of them, you have to provide solution either as exact value or round your answer to 2 decimal places. The next set of question is solve each in the interval minus pi to pi, provide exact solution or round to 2 decimal places. Now this time we have changed the interval and the questions taken involve quadratic equations with sine and cosine as the elements, right? So slightly more difficult than the first set of questions. And the last question here is extremely important from examination point of view. Now this type of question is asked normally in examination. We have taken first part of the question is prove that cos theta minus tan theta whole square plus 1 plus sin theta whole square is equal to 2 plus tan square x. So that's an identity. First you have to prove this identity and then use this identity or otherwise you may solve the given equation. The equation is solve cos x minus tan x whole square plus 1 plus cos x whole square equals to 3, where x belongs to 0 to 2 pi. So as you can see, I could have given a direct question here, but then it becomes extremely difficult. This really helps students to understand how should they attempt to solve such a question. So once you know that all this is equals to 2 plus tan square x, then basically we are trying to solve 2 plus tan square x equals to 3. So that becomes pretty simple. Now here is my thought about it. Suppose by any chance, if you do not get solution of part A, you know what part A leads to. You can use this information to solve part B and at least get marks for part B. Now, this is a very important examination strategy. I hope you have understood the facts and also how should we attempt a test paper in examination. Now, with that in mind, let us now begin to look into their solutions. So, first thing first, since we are looking into radians, your calculator should be in the correct mode so that you get all your answers in radians. For most of the questions, we'll need calculations to be done using the inverse of these trigonometric ratios to find the required angle in the given domain. That is kind of important. So let's see the first question once again. It says solve each in the interval 0 to 2 pi, provide exact solution or round to two decimal places. So keep this in mind while you are solving these questions. So let's begin with the very first one, which is tan x equals to 0.5. Now 0.5 means we are looking for a positive value. First thing first, we can find what x is equal to using the calculator. So x is equals to tan inverse of 0.5, correct? And we can use the calculator, find the answer. However, we need to understand one thing very clearly, that there are actually two answers for this within 0 to 2 pi, correct? So how do we find both the answers? So here I would like to make a small sketch, coordinate plane, and we know in a coordinate plane the cos rule. We are looking for a positive value of tan. That means the answer should be either in quadrant 1 or in quadrant 3. Correct? And tan has a period of pi, right? So tan has a period of pi, as you can see here. So we'll add pi to get the second answer. So that is the strategy. Let us use the calculator and find what is tan inverse of 0.5. Well, it gives you a value which is 0.4636. So x is 0.4636. So we're writing to four decimal places. However, we have to round them to only two decimal places. So we can write this answer to the required decimal place as 0.46, correct? So that is one of the answers. Now, what is the other solution? The other solution will be, this is, we say the first value, so we say x is equals to this, or x is equal to 0.46 plus pi. So we'll add pi to this and find the next answer. So adding pi gives us 3.60. And now we can write down the solution that x is equals to 0.46 or 3.60. So that is how we will move forward. So I hope this concept is absolutely clear. Now here is the second question, which is cos 2x equals to 0.315. I'd like you to pause the video and answer this particular question. And the solution should be within the domain 0 to 2 pi. So cos 2x is positive in which quadrant? Let's look into that first. So we know the cos rule. So that gives you cos as positive in quadrant 1 and in quadrant 4. Since it is cos 2x, you can think about going twice around this. And when you do so, you can clearly see that you get four solutions. 1, 2, as I'm marking here, right? 3 and 4. All in quadrant 1, two of them, and two of them in quadrant 4. So there are four solutions which we expect. Keep this in mind while solving the question. Perfect? Now, let us solve the equation. We are given cos of 2x is equals to 0.315. Let us write this as the related acute angle beta. So we can write this as, we will find the acute angle first, right? So we'll write this as cos beta equals to 0.315. Well, acute angle helps us to give all the four solutions. So let's say first we'll find the angle beta itself. So that gives you that beta equals to cos inverse of 0.315. Let's use the calculator. It should be in radians to get the value of beta. So it is shift cos inverse of 0.315, and that is equal to 0.125. No, 1.25. So it is 1.25033. So we have written to 1.25. So we know now that beta is 1.25. Now what are the other angles? The other angles will be what? We got one of the solutions. Since we are looking for solutions in quadrant 1 and in quadrant 4, correct? So we have four of them. So one of them is 1.25. The other one will be 2 pi minus 1.25. And then another 2 pi will be added to both of them. So we have 2 pi plus 1.25 plus 4 pi minus 1.25. Do you see these four solutions? These are the four solutions for the angle 2x. Perfect. So we found that 2x should be equal to all these. So once we find acute angle, we'll know all possible answers for the given angle, which is 2x. Let's calculate these values. Well, one of them we know is 1.25. The other one is, let's do with calculator. 2 times pi minus 1.25 will give us 5.033. I'm writing to three decimal places. And now to this, we are going to add more 2 pi to get the last value. So I'll add to this plus 2 pi. This is 11.31. And to 1.25 also I'll add 2 pi. 533. Now these are the angles in radian for 2x. So what is the value for x? We are going to divide them each by 2 to get the value for x, right? So we get 1.25 divided by 2, 5.033 divided by 2, 7.533 divided by 2, and 11.31 divided by 2. So that gives you the possible values for x. So 1.25 divided by 2 is equal to 5 by 8, which is 0.625. So we could write exact value of 5 by 8. Then we have 5.033 divided by 2, 2.51, round 516. So I'll write 2.52. 7.533 divided by 2. It is 3.77 when rounded, and 11.31 divided by 2 gives us 5.655. So I'll write this as 5.66. Do you see that? That is how you have to write your solution. Now, this is one way of doing it. There's an alternate way. That means we could have added the period also. However, we'll understand this method for this particular solution. Now, here are question number 3 and 4, which you need to solve. Now you can actually pause the video, answer the question, and then look into my suggestion. Question number 3 is 2 of cos x plus 1 equals to 0. So cos x is equal to minus 1 divided by 2. Now we have a negative value for cosine. So the solution should be in which quadrant? Well, the solution should be in quadrant 3 and 4, right? Those are the values which are negative for cosine, since you know the cost rule clearly. And then in one full circle, which is 0 to 2 pi, we expect how many solutions? We expect two solutions. So now, to find these solutions, we should first find the related acute angle. So the related acute angle, let me say the related acute angle is beta. So we can say cos beta is equals to half. Since the related acute angle is always in quadrant 1, it will be positive value. So beta equals to cos inverse of half, right? So that gives us beta as equal to shift cos inverse of half, and that is pi by 3. You could use special triangle to answer this question also. So we have an exact value, pi by 3. Remember, since the value required was half, I could have drawn this right angle triangle, in which we know that for pi by 3, the special triangle, the sides are 1 square root 3 and 2 is the hypotenuse. So from here, for half, we know cos should have been pi by 3 as we used calculator and figured it out. Now the other value will be how much? So that becomes one of the solutions. So we can say x is equals to pi by 3, and the other value is, x is, we are looking for cos of minus half, right? So that is the related acute angle. We are looking for solutions in quadrant 2 and in quadrant 3. In quadrant 2 and 3, as you can see, the answer will be x equals to pi minus pi by 3 and pi plus pi by 3. Is that clear to you? So that gives you x value as 2 pi minus 1, 3 pi, 3, you can write 3 minus pi, or you can write 2 pi by 3. Okay, so that becomes your answer. Here, 3 plus 1 is 4, so we can add 4 pi by 3 as your solution. So that becomes the answer for the exact value. I hope that is absolutely clear, right? Now let's look into the next question, which is sine of half x is equals to 0.09. Now in this, domain will change because now the argument is half x. So let's understand this change of domain. We are looking for x to be between 0 to 2 pi. Now half of x will be between what? Dividing by 2, we get 0 to pi. Correct? So that is what we are expecting. Since we are looking into only half of the wave, right? So within the whole interval, we only expect half of the wave. We know from the cost rule that sine is positive in quadrant 1 and 2, and therefore the solution will exist for a positive value in 1 and 2. So if I draw this half wave also, I do get two solutions. So in this case, I am expecting two solutions within this interval 0 to pi for half x. You get the idea, right? So we can find the related acute angle, which is also a part of solution, correct? So we'll solve for related acute angle and then calculate the answer. So in this case, let us say we are do sine of theta. Sine of beta equals to 0.09. So beta is equals to sine inverse of 0.09, which is, let's calculate, shift sine inverse 0.09. 0.09. You see, for small angles, we have in radians, sine theta is almost equals to theta. Very important to see from here, right? So we have beta as 0.09. Now the other value of angle will be what? So we can say now that half of x is equal to 0.09, and the other value which we see within 0 to 2 pi is 2 pi plus 0.09, right? Pi minus 0.09. Pi minus 0.09. So let's calculate this. So we get half of x equals to 0.09 and pi minus was 3.05. Correct? X will be equal to double these values, right? So it will be 0.18 and 3.05 times 2. We get this as 6.10. As you can see, the value of x is in fact between 0 to 2 pi, correct? So remember, what is 2 pi equals to? We know 2 pi is equals to 2 times shift pi. We get value as 6.28. So you can see that this is within the domain. And these are the two solutions which we get for this particular equation. So I hope this is absolutely clear to you. Now let's look into the next question, which is the equation of the form 3 minus 4 sine x minus pi by 3 equals to 0. Now, in this particular equation, what do we see is that first we need to simplify, of course. Let's do that part. So we have 3 minus 4 sine of x minus pi by 3 equals to 0. So we can reorganize. So we get sine of x minus pi by 3 equals to 3 divided by 4, correct? So that becomes our equation which need to be solved. Since the value is positive, we expect again the solution in quadrant 1 and in quadrant 2, sign being positive. Now this has been translated x minus pi by 3. So it has moved pi by 3 units right. So remember this part. So this portion has moved pi by 3 units right. Perfect. Keep that in mind. So first thing first, let us first find the related acute angle, right? And then we'll find all other solutions. So here the acute angle beta will be equals to sine inverse of 3 by 4, and that is equal to 0.848. The other solution will be what? Well, the other solution will be, if that is the acute angle, pi minus this, and then we have to, so the other solution will be, this is one of the solutions. You can say that x minus pi by 3 is equal to 0.848, and the other solution will be pi minus 0.848, correct? So we have this equals to 0.848 and pi minus 0.848. That gives us 2.293. So that is x minus pi by 3. Now if you find what x is, you have to add pi by 3 to this, right? So we have 0.848 plus pi by 3, and we have 2.293 plus pi by 3. So let's add pi by 3. Add shift pi. 3.34 as the other value, and the first value is 0.848 plus pi divided by 3 equals to 1.895. Now rounding them to two decimal places, we get 1.90 and 3.34. And both of them are within 0 to 2 pi, and so that is the solution for this particular equation. The next one here is tan 2x plus pi by 6 equals to 2. We're looking for a positive solution. So that means we're looking for a solution in these two quadrants. They are quadrant 1 and 3, correct? Since tan is positive in quadrant 1 and in quadrant 3. Now here one thing is to be noted, and that is the equation should be written properly. So we have tan of, it is a good idea to factor out 2. So that becomes the horizontal compression by a factor of half, and that gives you x plus pi by 12. Do you get that? Equals to 2. So now what we have here for tan, we have tan 2. So normally the period for tan is, this is a very important approach. So period for tan is what? Let's say tan x will be is pi, correct? So period for tan of 2x will be half of that. So period is pi by 2. So each solution will repeat after pi by 2, correct? You get the idea. Pi by 2 in radians is how much? I mean, pi by 2 as a decimal number is how much? Pi divided by 2. Let me write down the decimal value, 1.57, or which is equal to 1.57. So that means each value, if this is one value, then the other value will be, if this is, let's say, beta, in that case the other value is pi plus beta. But since we are talking about 2x, the period is pi by 2, right? So let's figure out the answers now. So beta equals to tan inverse of 2, which is how much? Shift tan inverse of 2 is 1.107. So that is the value of beta. So now what we can do here is first calculate this value and then add the period to get all other values. So I'm writing at this stage the value for 2 times x plus pi by 12 equals to 1.107, right? So x plus pi by 12 is equal to half of this, which is divided by 2, 0.553 round to 6, right? So x is equal to 0.5536 minus pi by 12. So we'll take away pi by 12 from here. I hope you are getting the concept, right? We're just trying to solve for the acute angle. So it rounds to 0.29. So for the given function, we have got the first solution as 0.29. You get the idea. We know that within 0 to 2 pi, we'll have two waves. That means we are expecting four solutions, right? So we are expecting two waves. You see that? So we are expecting two solutions. We have got one of them already, and all are one period away. Since the period is pi by 2, we will add 1.57 to get other solutions. Correct? So we have one solution, x is equals to 0.29, and then we have 0.29 plus 1.57, that is first. And then we have 0.29 plus 2 times 1.57, and then we have 0.29 plus 3 times 1.57. You get there. So these are the four solutions which we will get. So we can write down all the solutions from here. So we have x equals to 0.29 as the first one. The second, we'll add 1.57 to it. And keep on adding 1.57. That's the whole idea, right? So 1.86. Then again add 1.57. So you get 3.43. And then again add 1.57. 5.0. See, if you now add 1.57, what happens? You get 6.57. Do you see that? Which is out of range. So you get an idea how by adding the period of the function, we can find easier solutions faster than what we did before for question number 2. You remember question number 2? And now in question number 5, we have adopted a different approach. So this is a more effective way of finding solutions. Another method to do. So these are the four solutions for the given equation tan 2x plus pi by 6 equals to 2. Question number 7. Solve each in the interval minus pi to pi. Provide exact solution or round to two decimal places. See, when we are saying minus pi to pi, remember sine and cosine functions. Let me sketch the graph first, just to give you an idea. So if you're talking about the trigonometric functions, now we're saying from minus pi to pi. So if it is a sine wave, we are interested in the interval from not from 0 to 2 pi. You get the idea, correct? We are interested in minus pi to pi. So half of this to half of this. So that is the portion which we are interested in. Similarly, if you're talking about the cosine wave, let me sketch cosine wave also. Because this is a cosine function, let me sketch here. We are really interested in, so that is 0, right? And then pi by 2 and pi, correct? So we are looking into this interval. You get the idea. That is where we are looking for the solution from minus pi to pi. Now let's try to solve. The question is 4 cos square x equals to 1. Cos square x is 1 by 4. So cos x will be plus minus square root of 1 by 4, which is plus minus half. Since it is plus minus half, we are reminded of our special triangle. We can use pi by 3, 1, 2 square root 3, and we know that the related acute angle is pi by 3, correct? So we have one solution here, which is related acute angle of pi by 3. The other solution, it is actually plus and minus, so we're looking for all four solutions. Perfect. So we have to go plus minus pi by 3 will give you these two solutions, and then we're looking into, so when we say plus or minus half, as you can see here, I could draw a line. No, that is a sine wave, sorry. In this case, if I draw a line, I do get four solutions within this interval. So we're looking for four solutions as shown here, and the related acute angle is pi by 3. So the solutions are x is equals to plus or minus pi by 3. So that is, both of them are within minus and plus pi, correct? And the other value will be 2 pi by 3. So from we can take away pi from each. Let me draw this slightly bigger to explain you the concept. What we got here is one of the solution as pi by 3. Correct? So from here we can say that the other solution is, because cos is positive here also, so pi by 3. You see both these angles are within plus or minus pi by 3. And then we have this solution. Do you see that? So to get to this point, which is minus, we have to see this angle. Do you see that part? So that means pi minus pi by 3 or minus 2 pi by 3. Perfect. And the fourth solution will be, if you go from here, it is less than pi, correct? And that is 2 pi by 3. So the other solution will be 2 pi by 3 as shown there in the diagram. And these are within the interval minus pi to plus pi, correct? So you can write down these four answers and you get x value as equals to plus minus pi by 3 and plus minus 2 pi by 3. Is that clear to you? As shown here for cosine function, right? So this is for question 7. Now let's look into question number 8. Here we have a trigonometric equation in quadratic form. 4 sine square x plus 4 sine x plus 1 equals to 0. Let me rewrite the equation. It is 4 sine square x plus 4 sine x plus 1 equals to 0. You can factor this as 2 sine x plus 1 whole square, right? It is a perfect square. Product of 4 and sum of 4, right? So if you square it, you get this equation. And clearly, the factor 2 sine x plus 1 should be equal to 0. That basically means that sine x equals to minus half. Now when I say sine x is minus half, so in this diagram, minus half will be kind of like this, right? So the two solutions will be in quadrant 3 and 4, right? That is where we get minus half. And within the given interval, one of the solutions, and this is the other solution. Is it clear to you? Well, we can again use the same triangle, and clearly, for sin x equals to minus half, well, the related acute angle is pi by 6, correct? So we have pi by 6 and pi minus pi. So this is minus pi by 6, since we are going in this particular direction, which is clockwise direction. So we are going clockwise. Negative angle. Correct? So we can write down that x is equals to minus pi by 6, and the other solution will be right there. Do you see that? So it is minus of pi by 6 you can write, correct? So this is 5 pi by 6. So therefore, for this question, we get x equals to minus pi by 6 and minus 5 pi by 6. Clear? And these are as shown in the coordinate plane within the interval minus pi to plus pi. So let's move on and take up the next question, question number 9 and 10. Again, remember, we have to find the solution within minus pi to plus pi. So we this time have a quadratic equation in cosine. Cos square x plus 2 cos x minus 3 equals to 0. So factor this equation. Product of 3, sum of plus 2. That means 3 times 1 will work. So I could write this as cos of x plus 3 times cos of x minus 1 equals to 0. That means, well, this is not valid. Since it does not exist, cos value cannot be negative 3. But here we get one solution, which is cos x equals to 1. And within this interval of minus pi to pi, when is cos x 1? So at 0 and at pi, right? So we have the solution x is equal to 0 or x is equal to minus pi. Now pi will also work, or x is equals to pi. So there are three solutions in this particular case for the cosine function. Now when is cos x equals to 1? Well, cos x is equal to 1 at 0. We are looking into this interval of pi minus pi to pi, right? So let me sketch cosine function once again so that it's absolutely clear to you. If I'm looking at minus pi to pi, do you see that? So there is only one value where it is 1, and therefore x equals to 0 is the only solution in the interval minus pi to pi. Clear? Let's look into question number 10, which is 3 sine square x minus cos square x equals to 0. Now, since we have combination, well, what we could do is we can rewrite in terms of tan, right? So I'll rewrite this equation. So we have 3 sine square x equals to cos square x. Dividing by 3 cos x, what do we get? So we get, let me do that. So we have, let me say it like this, sine square x over cos square x, let's cross multiply, equals to 1 over 3. Not bad. So that gives us tan square x equals to 1 over 3, or tan x equals to plus minus 1 over square root 3. Clear? Now in this case, we can use a special triangle. Pi by 3, right? And pi by 6. So we're looking for plus minus 1 over square root 3. So the angle is pi by 6, correct? So we know one of the solution x is pi by 6. So once again, if you look into the coordinate plane, we're looking into solutions from plus and minus pi. So we have two solutions counterclockwise and two solutions in this direction, correct? The angle being pi by 6. Do you see that? So now we know this is pi by 6, that is minus pi by 6, correct? And this is 1 less than pi, pi by 6 less than pi, so 5 pi by 6 and minus 5 pi by 6. Is that clear to you? So we have our answers minus pi by 6, 5 pi by 6 and minus 5 pi by 6. Perfect. That is how you can understand the solution of the given question. I hope this makes it absolutely clear. We are almost at the end, two more questions to go, rather four. We'll continue with solving equations within the interval minus pi to plus pi, and this time the equation is 4 sine square x minus 5 sine x plus 2 cos square x equals to 0. Now to write it in quadratic form, I'll write down cos square x in terms of sine, correct? So we'll simplify this first. Two times 1 minus sine square x equals to 0. So we get what? 4 sine square x minus 5 sine x plus 2 minus 2 sine square x equals to 0. 4 plus 4 minus 2 is 2 sine square x. We get 2 sine square x minus 5 sine x plus 2 equals to 0. So 2 times 2 is 4. We need minus 5. So 4 times 1 can work. So this can be factored. We have 2 sine square x minus 4 sine x minus sine x plus 2 equals to 0. So here we can take 2 sine x common. So we have sine x minus 2, and here we have sine x minus 2 with taking minus common. So now sine x minus 2 is one of the factors, and the other factor is 2 sine x minus 1 equals to 0. That gives you that sine x is equal to 2, which is not valid. The other one is sine x equals to half. So that will give us solutions, correct? So within the interval of minus pi and pi by 2, we're looking for in this direction and in this direction, correct? So sine x is half in quadrant 1 and 2, and therefore we do have two solutions. The triangle, again, which will be, as you know, we'll use the same triangle. We're looking for values of half, right, for sine x. That means pi by 6. So x is equals to pi by 6 and 5 pi by 6. So these are the two solutions for the given equation. Perfect. Let's take up the next question, which is very similar to this one. Sine square x minus 3 cos x plus cos square x equals to 2. So I'd like you to pause the video and do this, but this time sine square x will be written in terms of cos to get you the equation in cos, correct? So you could write this as 1 minus cos square x minus 3 cos x plus cos square x equals to 2. And that gives you, we can bring all the terms to the right hand side, 0 equals 2. Since, um, well, cos square x cancels, and we have 3 cos x here. Let's keep it this side only, and then we'll later take the numbers on the other side. So from here, you see that cos square x and cos square x cancel, right? So we are left in cosine x. So we can write this as 1 minus 2 equals to 3 cos x. That is the simplest solution. So we have cos x equals to minus 1 over 3. Is that clear to you? So cos x is minus 1 over 3. Cos is negative in which quadrants? In quadrant 3 and in quadrant 4. So we have one solution going clockwise, the other one going counterclockwise when we are looking into the interval from minus pi to plus pi. So let's use the calculator, find the related acute angle beta. So we'll say that let's cos beta is equal to 1 over 3. So beta equals to cos inverse of 1 over 3, which is shift cos inverse of 1 divided by 3 is equal to 1.23. So we know one angle, the related acute angle is 1.23. So the other angles will be pi minus 1.23 and negative of this, right? So we can write this as plus and minus. So we'll do pi minus 1.23. 1.91. So we get the value of x as plus or minus 1.91. Do you see that? So that is how we are going to find this particular solution. Here is the last question, question number 13. Part A is, prove that cos theta minus sin theta whole square plus 1 plus sin theta whole square equals to 2 plus tan square theta. So I should have written here theta. Correct. Now part A is actually related with the trigonometric equation, which is once you do this, after that you have to solve the equation that cos x minus tan x whole square plus 1 plus sin x whole square equals to 3. Now it is important to note that in examination, let us say you are unable to answer this question. In that case, you can use this result and then solve the equation 2 plus tan square theta or x is equal to 3. You'll get marks for at least the last part. I hope you get the idea. Let us see how do we prove the identity first. So the identity given to us is cos theta minus tan theta whole square plus 1 plus sin theta whole square. So that is the left hand side, right? We'll expand. So we get cos square theta minus 2 cos theta tan theta plus tan square theta. And the other term will be 1 plus 2 sin theta plus sin square theta. See, we want 2 plus tan square theta. We already have tan square theta here. Do you see that matching? So I'll leave this tan square theta as such and try to rearrange and solve or simplify the other terms. Well, cos square theta and sin square theta adds to 1. So let's write them together first. So we have cos square theta plus sin square theta. So I'm reorganizing minus 2 cos theta. Tan theta can be written as sin theta over cos theta plus tan square theta, and then we have 1 plus 2 sin theta. Now, cos square theta plus sin square theta is 1. So, for this, we'll write 1. And here we can cancel cos theta and cos theta. So, what we get here is minus 2 sin theta. The term required, which is tan square theta, is there with us still. And then we have plus 1 plus 2 sin theta. Now, plus 2 sin theta and minus 2 sin theta will add to 0. Perfect. And 1 plus 1 is 2. So, we get the desired result, which is 2 plus tan square theta. That is the right hand side. Is that clear to you? So, by expanding, we have actually simplified and proven the identity. So, have a good look at it. It's a very important question. So, I hope you now get the solution. Now, let's move on to part B. We have already shown that this expression on the left is equal to 2 plus tan square theta. The question here now is solve cos x minus tan x whole square plus 1 plus sin x whole square equals to 3. So if I rewrite this question, it will be cos x minus tan x whole square plus 1 plus sin x whole square equals to 3. Now we know that this left side is basically equals to 2 plus tan square theta. So I'll replace that by 2 plus tan square x equals to 3. Now we can bring the terms, the numbers on the right hand side, getting 2 tan square x equals to 3 minus 2, which is 1. So tan x will be equal to plus minus square root of 1, which is plus minus 1. We need to find the solution within the domain 0 to 2 pi. So as you know, tan is 1 by pi by 4, correct? So the four solutions will be as shown here. Within 0 to 2 pi, we have pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4, correct? So we have the solution as x equals to pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Since the interval given to us is from 0 to 2 pi. Is that clear to you? So with that, we come to an end of this very important video where we are working with solving trigonometric equations using radians. So we began with simple questions, just finding the angle within 0 to 2 pi for one expression on the left side equal to a constant. And then we kind of complicated the situation, changing the domain as you can see. And then we went on to from linear trigonometric equations to quadratic trigonometric equations. And at the end, we solved examination style question where identity has to be proven first and then the equation is to be solved. I hope you understand and appreciate what we have done here. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.
I hope you find my video useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.